Okay, picture this, a computer that's so secure it has zero connection to the outside world. No internet, no Wi-Fi, not even Bluetooth. It's basically a digital fortress. But what if I told you that even that fortress could have its deepest secrets stolen, using a method that sounds like it's straight out of a spy movie?
The answer, believe it or not, is a big yes. In this explainer, we're going to dive into a fascinating, and let's be honest, pretty terrifying attack that literally turns a computer's own memory into a secret radio transmitter. It's the kind of thing that makes you rethink everything you thought you knew about digital security.
So we're going to break down this attack. It's called RAMBO, which stands for RAM-based overt covert channel. It is an incredibly clever and, well, deeply unsettling technique. And it's just a perfect example of how hackers are always finding new ways to get around our defenses.
Yeah, you heard that right. The crucial point here is that a piece of malicious software can take one of the most basic, fundamental parts of your computer, its RAM, and weaponize it, turning it into a tiny radio station. This lets it broadcast sensitive info completely under the radar, bypassing all the usual network security we rely on.
First, let's talk about the target here. We are not talking about your everyday laptop. We're talking about the most secure type of computer system you can possibly imagine, what we call an air-gapped computer.
So think of these things as digital vaults. They're what the military, intelligence agencies, and places that run critical infrastructure use to protect their absolute most sensitive secrets. The entire point of an air gap is to create a physical barrier, a moat, to make sure nothing gets in, and even more importantly, that nothing gets out.
But here's the thing. As history has shown us time and time again, even this fortress is not completely impenetrable. Really determined attackers have found clever ways to jump that air gap. A lot of times they use things like infected USB drives, or maybe even an insider to sneak their malware onto these isolated systems. And that's really just the first half of the problem, getting the malware in. The second, harder part is getting the data out.
Now, this is where it gets really mind-bending. The way RAMBO creates its signal, it doesn't need a Wi-Fi card or any kind of transmitter. Instead, it uses the fundamental laws of physics to turn the computer's own hardware against itself.
So get this, every single time your computer's processor reads or writes to its memory, it creates this tiny unintentional electromagnetic buzz. It's just a side effect of electricity moving around. While the RAMBO malware hijacks that buzz, it performs super-specific, high-speed memory operations to control the frequency of those waves. It's basically spelling out secrets in a kind of Morse code for radio waves, a secret language that only the attacker with the right receiver can actually understand.
And what's really cool is how the attackers can pick different languages for this secret broadcast. They can use a really simple on-off method, kind of like blinking a flashlight to send a signal, or they can go with something more complex called Manchester encoding, which is way faster and more reliable, but it's also a bit louder in the radio spectrum. It's this constant trade-off, right? Speed versus stealth.
Okay, so this all sounds very clever, but how effective is it really? How much damage can this invisible data leak actually do? Well, the results are, frankly, alarming. Just let that sink in. A little over 4 seconds. That's all it takes to broadcast the crown jewels of a system's security, a really powerful encryption key, silently, to a nearby receiver. That's less time than it took me to say this sentence. It is an incredibly fast and just devastating kind of breach.
And we're not just talking about keys and passwords. To prove this actually works, the researchers managed to pull out files, biometric data, and even entire images, like this one of Optimus Prime of all things, from a completely isolated computer. It just goes to show you that pretty much any kind of data is vulnerable.
This table really puts it all into perspective. I mean, look at these numbers. A password can be gone in a fraction of a second. That sensitive text document leaked completely in less than a minute. For a system that is supposed to be perfectly physically secure, this is nothing short of a catastrophic failure. And it really highlights just how badly we need new ways to defend these systems. So now that this vulnerability is out in the open, the big question is, right, how do you defend against an attack that turns a computer's own memory into a weapon? Well, as you're about to see, the answer is not simple.
Security experts have come up with a bunch of potential countermeasures. They range from software-based solutions that, try to look for suspicious memory activity, all the way to physical ones that try to just block or jam the radio signals. But each of these comes with its own major set of challenges.
And as you can see from this slide, there's no free lunch here. Every single solution has some serious trade-offs. If you try to monitor the software, you get tons of false alarms, flagging normal computer processes as an attack.
If you try jamming the signal, you might end up disrupting the computer's actual functions or messing with other electronics nearby. And the physical solutions? Well, they tend to be really expensive and just not practical on a large scale. There is no silver bullet.
Really, the most effective solution is to physically shield the computer in something called a Faraday cage, which is basically just a metal box that blocks radio signals. But, as the researchers themselves point out, this is super expensive and you just can't do it everywhere. It's a fix for maybe a handful of supercritical systems, but not for the thousands and thousands that are at risk.
So, all of this leaves us with a really critical question. The RAMBO attack proves that even in the most locked-down, isolated environments, vulnerabilities can pop up in the most unexpected places, not from the network, but from the basic physics of the hardware itself. It forces us to ask, if a computer's most fundamental components can be turned into a weapon against it, what does it even mean to be truly secure anymore?